Hello friends, welcome back to our channel. So in the previous session we have discussed about the creation of arrays with the existing data, and in this session we will move with a few more functions which are available to create the arrays with the numerical ranges. Okay, so arrays with numerical range, right? So we know that we can create an array by using the array function in Numpy. So we are discussing about this module Numpy. So in order to create an array, we have to use the array function, and in that function we have to pass some parameters, right? So the sequential iterables we can pass to the as a parameter to the array function, so that an array will be created. And now we will see how to create these arrays using the numerical ranges. So here we are having mainly the three functions. Okay, the first function is Arange function. Arange function. So I will discuss about the parameters later. So next, Linespace function, Linespace, and Logspace. So mainly we are having the three functions to create an arrays in the Numpy with the numerical ranges. So in all these three we have to pass the numerical ranges. That means numerical range. So these three functions will return an array. So all these three functions will return array with values in given range and required data type. Okay, so all these three functions we have to pass the numerical range as a parameter, and all these three functions returns an array with the values in the given range. So here we have to give the range, and within the given range it will return some values and with the required data type. So commonly for all these functions we have to pass the start index, the stop index, right, and dtype. So these three are the common parameters we have to pass to all these three functions. So apart from these three parameters we have to pass a few more parameters, so we will discuss, but by default these three are the parameters we are supposed to pass in these functions. So this is an optional, data type is an optional. So if you are not giving any data type, so it will be treated and it will return some data type values. Okay, so if you want to specify some particular data type, we have to use this dtype argument. Okay, and the start index and stop index, so this is normal, we know that. So within the given range of index values, it will take the values, it will consider the values and it will store it to an array. Right, so we'll move on to the one by one, the function one by one. So see, coming to this Arange. Okay, I will erase everything and we'll discuss each function. And don't worry, I will execute all these three functions. I will demonstrate all these three functions in the interpreter later after completion of this theory part. Okay, so the first one is Arange function. Arange. So as we know, these functions are in Numpy module, right? First we have to import the Numpy module. We can give some alias name. So Numpy as np. So we have to call this function by using the alias name np.array. So what are the parameters required? First one is the start index. The second one is the stop index. And the third one is the step size. That means the difference between the values. Okay, and the fourth one is the dtype. So these are the parameters taken by the Arange function. So this is completely similar to our range function which we have discussed in the iterative statements. So in the iterative statements we have discussed about the range function, so that all the values within the given range will be stored in the some particular it will be iterable, right? So the same thing here in the arrays concept, we are having some range function, and apart from these three parameters we are having the additional parameter called dtype. So that means we can give the required data type. So if you pass this dtype as a integer, we will get all the integer values. If you pass this dtype as a float, we will get the float values, right? So np dot range of some 0, 10, 2, dtype is equal to integer. Okay, so this will give all the values between 0 and 10, which is not included. The end index will not be included here, right? So dtype integer. So we'll get an array of 0, 2, 4, 6 and 8. Okay, if it is a float, we'll get 0 point, 2 point, 4 point, 6 point and 8 point. Okay, here we are giving some integer values, so these precisions will not be there. 0, 2, 4, 6, 8, and this is not a list. See, the differentiate, how to differentiate a list and array. So list will be like this: 0, 2, 4, 6, 8. So these are the comma separated values, right? So these are the comma separated values, and this is an array. That means a space separated values. Here we should not use the commas. So that's the only difference between the list and array. So we can differentiate these two things. Okay, so this is how we can use the arange function, a simple function. Okay, so now we'll move on to the next one. Don't worry, I will execute the same function in the interpreter, so that if you are having any doubts still, so those doubts will be clarified. Right. Next, we'll go with the second function, that is a Linespace. So here also we have to pass np dot Linespace, and the first parameter is common, that is start index, and the second parameter is a stop index. So we have to give the stop index, and the third parameter is not the step size. Here we have to give some number. Okay, and then the fourth one is endpoint. So I will give you the description. So what is the use of all these parameters? The next one is a return step, and the next one is a dtype. So this will having all these parameters, right? So start index means, so we know that start index and stop index. Okay, we have to give the ranges. So it will consider the values in given range. Okay, given a range. That means we can treat it as lower boundary, and this will be treated as upper boundary. So within the given range we have to get the values. Next one is a number. Number is nothing but the return values. So how many values we have to get, right? It returns the number of required values in array. So that means if number is 2, the array will be having only 2 values. If the number is 3, the array will return array with the 3 values. If you give number is equal to 5, the function will return the 5 values, array with the 5 values. So this is an optional. So that means if you are not giving any value here, so by default this value will be 50. So that means if you are not giving any value for this number, so it will return 50 values. Okay, 50 values. So now next one is endpoint. Endpoint means whether we have to include the stop index or not. So coming to the previous function we have discussed, so there is it will include the start index and it will exclude the stop index. But here, if the endpoint is true, stop index will be included. So the value of stop index will also be added, right? It will also be included. So if it is false, stop index is not included. Okay, stop index will not be included. Right. So if we take the range as some 0 to 10, so if it is true, the 10 will also be included in the given list, and if it is false, 10 will not be included. So it will be ranges from 0 to 9. Right. So that's the importance of this endpoint. So by default, so this is also an optional thing. This is also an optional thing. So by default, that will be true. That means it will include the stop index. By default, it will include the stop index, right? So I will show you the demonstration of this function in the interpreter. Don't worry about that. And the next one is the return step. Retstep. Retstep is a return step, right? So return step will give the difference between the values. So if we get some number is equal to 5, we will get some 5 values here, some 0, 2, 4, 6 and 8. Okay, so 5 values will be getting. So what is the difference between these two? Okay, what is the difference between these two? So the difference between the samples, or the difference between the elements, or the difference between the values will be given as a return step. So it returns the difference between values. Okay, so it will return a tuple of the function, array function with the parameter, with the values, comma return step, the value. Okay, the difference between the values. And this is also an optional. Okay, so by default, so if it is a true, the value will be visible. Okay, the value will be visible. If it is a false, the value will not be visible. Right? So we can see the difference and we cannot see the difference. If it is a true, we can see the difference. Okay, so the difference will also be included in the result. And if it is a false, the result, the value will not be included. Okay, so it's also an optional thing. So by default, it will be false. So by default, it will be false. By default, it will be false. So by default, if you are not giving any value to this return step, automatically the value, the difference between the values will not be printed in the result. Okay, so this is how we can get the thing. Okay, we can get the return step. And the last one is the data type. We know that we can include the data type. So the required data type will be given. So it can be integer or a float. Right? So whatever the data type we are giving, so that the values will be of the particular data type. See, start index, stop index, and number is an optional. Okay, it's an optional thing. And this is also an optional. And this is also an optional. And this is also an optional. So we can simply give start index, stop index, and how many numbers we require. So if you are not giving how many numbers we require, by default it will be taking as a 50, and it will include the endpoint, and automatically it will not, the return step, that means the difference value will not be included, and the data type will be of float. Right? So this is how we can execute this Linespace. So example, np dot Linespace. Okay, Linespace, some 0, 10, number is equal to some 5, let it be. Okay, so 5 values, and the endpoint, I don't want to include the end index, so endpoint is equal to some false. So make sure that we should not enclose in quotations, right? So double quotations. Simply we have to write endpoint is equal to false, and ret step is equal to some true, so that it will be visible, and some dtype is equal to integer. Right? So this is an example for creating the Linespace. Right? So don't worry, I will execute this function also. I will show you the results, and we'll move on with the third one, and we'll directly move to the interpreter. Right? See, the third function is similar to the second function, that is Linespace. The third function is Logspace, np dot Logspace. So this is similar, but here we will get the log values, logarithmic values. Okay, so the starting index, The first parameter is start index, the second parameter is a stop index, and the third parameter is a number. So how many values we require, that is also seen. And the next one is the endpoint. Here instead of retstep we are having some base, so we have to mention the base. By default it will be 10, base 10, logarithmic base 10 values will be returned. So if you want to change the logarithmic values we require, so we can give the specified base, log2 base. Okay, and the last one is a similar dtype. Okay, and we know that start index, stop index is same. We have to give the range, so lower bound and upper bound. So the start index will be the lower bound, value, and the stop index is the upper bound value. And here num is equal to, so we can directly go with the num is equal to. So num is equal to means the values, the number of values required, and the endpoint. So here also by default it will be 50. Okay, by default it will be 50. So this is an optional thing. Okay, this is an optional. And the endpoint, so this is also, it's a true or false. Sorry. Right, so if it is true, end index will be included. If it is false, end index will not be included. So that's also an optional. So here the default one is true. Okay, it's also an optional thing, optional parameter, right? And the next one is a base. So base of log value, so we have to specify the base. Okay, and here also the default, the base value will be 10. Okay, this is also an optional thing. And the last one is a dtype. So here we have to mention either int or a float, the required data type which we want to get the values, and this is also an optional. Only one difference means, so when compared to the Linespace and the Logspace, here we get the log values. All the log values will be displayed, right? In the Linespace, the integer values will be given, within the given range values will be taken, right? So all the remaining concept is same. So hope you understood these three functions. So these three functions are the numerical range functions which are used to create an array, right? So by using these functions we have to create an array. Right, so hope you understood this three function syntaxes. Now we will see the practical implementation, the demonstration of all these three functions in the interpreter. Right, let's move on to the interpreter. Hello friends, so just now we have seen the different functions to create an array with the numerical ranges, and in that we have seen the Arange function, Linespace function, and the Logspace function. So Arange function will take the numerical values within the given range, and Linespace functions will generate the samples within the given range, the number of samples, and Logspace is based upon the log values. Right, we will see the implementation part. I will open the Jupyter notebook and I will show you the execution of these three functions. So Arange function is similar to the range function which we have discussed in the iterative statements, that is a range. So there it will be accepting three arguments: start, stop, and step size. Here also the Arange function will also consider these three arguments. Apart from these three arguments, one more arguments will be added, that is the fourth argument that is related to the data type. So we can get the numbers in a given range of required data type. So fourth one is the data type, D type. So first I will import the Numpy. Just I will give some alias name, and I have to call all these functions with the help of alias name, right? So np dot arange of, so start and stop we can consider the same. Some I will give a 2, and we can have the fourth argument dtype. So dtype is equal to, I'll give some integer, so by default it will be there. So if you get it, so we'll get an array function, an array of list. You can observe here it's an array of list. So we have, while we have studied that in order to create the array using numpy, first we have to pass this any sequence to the array function, right? So we are supposed to use this array function to create an array. So if you create the same thing, and if you initialize it that to one variable, then automatically if you print the same array, see, if you print the array, we'll get the array. So here you can see the difference between this result and this result, and this is a list of values and this is the list of arrays. So what's the difference? How can we differentiate the list and arrays? So here in the list, it's a comma separated values enclosed in the square braces, and the array is a space separated values enclosed in a square braces. So here we are not using any comma for separating the values, so that will be treated as an array, right? So if you observe the same thing, see, if you execute the same thing by taking the data type as a different float, right? So float, and I'll just print the array, print array. So you can observe we'll get the values in a float, 0 dot, 2 dot, or 2 point, 4 point, 6 point, 8 point. So point is nothing but a precision, so that implies that it's a float values, right? So this is a one function. We can create an array using the numerical range, that means a range. So we'll go with another function, that is a Linespace. Array is equal to np dot, so we'll take array 1, sorry, array 1 is equal to np dot. We have to call all these functions using the numpy module. So as I have given some alias name for this numpy, I have to call with the help of the alias name, right? So np dot Linespace. So Linespace will also give a range of numericals, but it will generate the samples. Okay, it will generate some values, and how many values we require, that should be given as a parameter. So here also the first parameter is the starting index, and the last parameter, the second parameter is the last index, and the third parameter is not step size. Here we have to give the number of values we require. So if I give some 3 values, we'll get the 3 values in between 0 and 10. If you give 5 values, so it will return the 5 values within the given range 0 and 10. Okay, so by default, and this is an optional, by default it will be treating as a 50. So by default, if you give 0 to 10, we'll get some 50 values. Okay, so I will give some 5. And next one is the endpoint. There is a one more called endpoint. So that implies whether we have to include the end index or not. Basically, in the range function or in the slicing functions, so if you consider some range of values, it will include the lower index and it will exclude the end index. So that should be decided with the help of this endpoint. And if it is a true, endpoint is equal to true, that implies we have to consider the end index. Okay, 10 will be considered. And if it is a false, endpoint is equal to false, the 10 will not be considered, and within the given range 5 samples or 5 range values will be considered. Okay, so by default this endpoint will be true. And if you observe here, so if you execute this one, so we'll get the values, 5 values. So this third argument is values, the number of values, required values, so not the step size. So if you execute this one, you can observe 5 values are there. So 0 point, 2.5, 5 point, 7.5, 10 point. So total 5 values. So here the 10 is also included. You can observe here 10 is also included. But whereas by using a range function, 10 will not be included. See, you can observe 0 point, 2 point, 4 point, 6 point, and 8 point. So 10 will not be included. So but here it will be by default it will be true. And if you don't want to include that thing, we have to set the endpoint parameters, so endpoint parameter as a false. So take care that we should not enclose these false or a true in between the quotations, right? By default it will be false, by default it will be true, and if you mention it as a false, it will, the end index will not be included. You can observe here. end index will not be included. Only 5 values, we require 5 numbers, so 0 point, 2 point, 4 point, 6 point and 8 point. 10 is not included here, right? So if you print it like this, by default endpoint is equal to true, so 10 will be included, so it will return some 5 values, equally separated values, right? So what is the difference between one value and another value, right? So if you want to know that thing, we have to go with the another parameter. So see, here we have to go with the another parameter, so that is return step. RETSTEP. So if you mention here it as a true, by default it will be false, so we can't know about that. So if it is given as a true, if you enter, it will return a tuple of the values comma the difference between the one value and another value. So here the difference between one value and another value is 2.0. Okay, you can observe here, first 0 point, next 2 point, next 4 point. That means equally distributed, that the values will be equally distributed. So by default the equally distributed value will be 2.0. Okay, so by default this return step will be false, so that in the result we can't able to see that difference value. And if you want to know what is the difference between the two values, we have to set this return step as true. So then we can get the return step, the value, what actually the difference between the two values, right? So once again I will show you. So if you don't want to add like this, that means if you are not giving any numbers, so what we need, I mean how many numbers we need, by default it will be treated as some 50. Okay, by default 50, the third argument is number and by default it will be 50, so you can count here, so that we'll get some 50. Okay, so this is a 50, right? 50 elements. So if you mention the third argument as any integer, that many equal number of elements will be created with the equal distribution. And if so here we are giving endpoint is equal to false, so 10 will not be considered, so 9.8 is endpoint. Okay, so hope you understood this one. So here we can also have the last parameter as a d type. Okay, data type, so we can give the data type as an integer or a float. Okay, see, we'll check it out. So d type is equal to integer. Okay, so we'll get the only the integer values. So by default it will be followed. If you are giving some integer, we'll get only the integer values. So previously, so you can observe here, see this one, we got everything in a float values, but here I am giving some d type is equal to integer, I am getting the values in integer data type. Okay, so this is all about the Linespace. So first one is the starting index, second one is the stop index, and the third one is the number of values we require. So by default it will be 50, and this is an optional. And endpoint, whether we have to consider the end index or not. So by default it will be true. So if you consider it as a false, it will be not considered, not included, right? And the fifth argument, that is a return step. So that means it returns the value, I mean the actual difference between the values in the given range, right? And the last one is the data type. So we can mention the data type so that we'll get the result in required data type, right? This is how we can execute this Linespace. And now we'll see the third function, that is a Logspace. Okay, so Logspace will give the working of Logspace is equal to the Linespace function, so it will also accept the similar arguments. So but it will return the values of logarithmic values. Okay, it will return the logarithmic values, that's the only difference. And here we have to additionally we have to give the log, that means a base value, right? So we'll see Logspace, and first one is the starting index, second one is the end index, and the next one is how many values we required. So and then the endpoint is same. Okay, the endpoint is same, so if it is by default it will be true, so it will be considered, the last index will be included, and I'm taking this false, so it will not be included, and I just want to print the same. So you can observe here, so we'll get all the logarithmic. So here we have not mentioned any base value, so then the base value, default base value will be 10. Okay, so if you want to change the base value, here we have to change as some 2. Okay, sorry, so we can have the argument. So base is equal to some 2, so that we will get the values of base 2, right? So we'll get the base values 2. So the total number of values we required is 4, so we got only the 4 values, okay, the base value of 2, right? Equally divided values with a base 2, and endpoint is false, so 10 will not be included. 10 will not be included. Okay, so see, so this is how we can get. So by default the number will also be 50 here, so we got all the 50 values, we got all the 50 values, we are not mentioning any number, right? So then we'll get the 50 values. So this is how we can create an array by using the Logspace function. So in this session we have seen these three functions, so which are used to create an array by using the numerical ranges. So first one is the Arange function, then Linespace function, and the Logspace function. And here also the last argument is a data type, so dtype we can give the required data type also, right? So hope you understood this session and these three functions, and if you are having any doubts regarding these three functions, feel free to post your doubts in the comment section, so that definitely I will try to clarify all your doubts. And if you really understood my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.